Okay, hello. For another day of streaming for building my TweetTextarea component. Today, hopefully, we have a little bit more time, so I'm hoping I'll be able to get all the tests for the URLs done, and that might even start working a little bit on the regular expression patterns for basically checking, and we'll basically try to build patterns that work for most of the rules that we have, if not all of them. And I'll explain basically what we're going to do once we get to that point, but for now let's just start working on finalizing the tests, because I've been working on these tests for a couple of streams now, and I really would like to get them done today. So let's start immediately. We were working basically on the URLs. We just have these couple of behaviors to implement. So yeah, let's just get started. So we'll come here and then start with this one, test not dot. Let me check something, not this. Looking at the wrong. Yeah, this is what I want. I know that if we have this and this, then all of it will be highlighted as one URL. But what happens if we have something like this? Google.com. Again, that's fine, but then what if we include this? Yep, that's what I expected. If we have this, yep, that all should be fine. Okay. Then we can, if we have two URLs, don't include the protocol. Not I wanted setting next to each other, nothing separating them, and they will be highlighted as one. So we have something like this. Do this, consider indicator. Let me check something quickly. It's weird. Okay, give me 1 second. I need to adjust something with the audio. Seem to be having something weird going on with the audio. Just need to figure it out. Give me 1 second. I'll just have to mute everything so I can figure it out. Thank you for the follow. Pedakin? Pedakin? I hope I'm pronouncing the name correctly. Yeah, sorry about that. I just had to adjust something with the audio settings. There was some weird things happening. So yeah, let's get back to this. So yeah, we're working here. So yeah, as I said, basically, this keep going to the wrong tab. So yeah, as I said, like when we have something like this, like for instance, if someone decides to type two URLs next to each other, it ends up basically being highlighted as just the one URL. Like if we type this, as you can see, it's just one URL, it's not highlighted as two different ones. Yeah, as you can see here, it's included all in one span, in the same span basically. So that's what we need to test for. So we'll do this editor.type okay, and I'll do this equal page.locator span.highlight and const html await editor.inner html, and then we'll basically do expect span to be visible and expect HTML to be something like, not something like, it's gonna be actually this exactly, class equal highlight and then google.com, twitter.com. Okay, so that will work, and then test if we have two URLs and the first one includes the protocol. Let's say next to each other, and they will be highlighted as one URL. Synchronous page, and we will copy this. So if we have something like this, they will still be highlighted. So if we copy this thing and paste it here, as you can see, again, it's highlighted as one URL, all basically in the same span. So that's what we expect. If we have two URLs, both including the protocol sitting next to each other with nothing separating them, then none of them will be highlighted. So let's go up here, just add something separating them. So we'll copy this one, and we'll do this HTTPS. Then what we expect is to be hidden, and then to prove it, let's just damn, I did something weird. As you can see, none of it is going to be highlighted because they both include the protocol, and that is actually not allowed. So this will be hidden, and then this will be just the paragraph. So I think we've covered this bit, so we can get rid of this one. Let's see what we have here. Okay. Test if we add the @ character before a highlighted URL, then the highlighting of the URL will be removed. So let me just scroll up a little bit. So this test will actually check that the once we add the @ character, then if something is valid as a user mentioned, it will be highlighted. But even if like, let's say that we have something like problem is yeah, not a lot of things are invalid as user mentions, but yeah, anyway, this test is not going to check if the user mention is highlighted, it's going to check if the URL is not highlighted. So that's what I'm trying to say basically. Const editor page.locator div, and I pressed my caps lock for some reason. Await editor.type google.com. Then let's 1 2 3 4 5 6 7 8 9 10, yeah, that's correct. For let I equal 0, I less than 10, and I plus plus, then await editor press arrow left, and then we will basically add the add character, const span, how are we going to do this? The problem is the span is probably going to exist. Okay, we'll just have to check for it. So we'll do this, highlight const.html await editor.inner, and then await expect span to be visible, and await expect HTML to be this. It will be at Google, and then .com will be outside. So if we do this, yep, that's what we expected. That's correct. Okay, we'll go back up, just copy this, and then let's just add more, and then all of this is going to be highlighted. So if we have this, yep, all of it is going to be highlighted. Just the .com bit is not going to be highlighted, and this is going to be treated as a user mention, not as a URL. So if the tweet is published and the user clicks it, it will treat it as a user mention and will go looking for that specific user. So let's see. If we add, yeah, we've covered this one. We've covered this one, and we just need to cover this one. Okay. Because this is going to be important, and we'll go up here. Let's see. Okay. Yeah. Includes the protocol. Then let's go down. I think yeah. So let's see what happens here. HTTPS, and then we add the character. Then what's going to happen is basically this. It will be HTTPS google.com, and none of it will be highlighted. So if we do this, none of it is going to be highlighted. And by the way, it's even if it's HTTP, it has nothing to do with HTTPS. It actually, I think, has as far as I know, it basically the main issue is this. It's not to do with HTTPS itself. Like if we remove HTTPS, it's not going to be treated as a full protocol, so it's going to be highlighted. So it has to do with including the semicolon and the 2 forward slashes. So if you do the same here, actually I just realized something. We will now have to actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so we'll make this 18 and then do the same here, and again none of this will be highlighted. So if we do this, yep, none of it is actually highlighted because it's not treated as a user mention, it's not treated as a URL. This should be hidden. Same thing here, and I guess we're done with user mentions. Now we probably need to do the same with hashtags. I think they work exactly the same way. So maybe let's just copy all of this. Let's just copy this and go hashtags. Yes. Okay. Wait, paste. Oh, sorry. Let's just then we will go here, and then we'll have this highlighted as a hashtag. So let's just test it. and we had this. Yep, it's highlighted as a hashtag. And same as true if we actually add hashtag. Okay, yeah, that's what we expected. Then if it includes the protocol, then it shouldn't be highlighted. Again, yep, that's what we expected. Again, nothing of this should be highlighted. Yep, that's again what we expected to happen. So we've basically covered all of that. I think we have something that wasn't covered in the expected behavior document, which is what happens with the cache tags if they come before, and I think they are treated the same way basically. So if we do that, yes, and okay, so we will just copy this one. Oh, okay. Yeah, I forgot that we had to basically build a lot of weird tests down here to cover special characters in the URL. So we'll do this and this and this. This works. What we'll do here, because the thing with cache tags is they have a limit on how many characters they can include. So the problem is it's not, if we add a cache tag before it's not going to be highlighted necessarily. It depends basically on, like, because this for instance is 6 characters, which is actually the limit of how many characters you can have in a cache tag. So if we add something like this, for instance, Amazon, then it's not going to be highlighted. So if we do this, google.com, and we add this, as you can see, it's highlighted, but once we start adding something else, it's not going to be highlighted. So yeah, it's fine. We're just gonna do that, and we'll expect it to be hidden in this case with just this thing for like one instance, basically, to make sure that we'll delete this one because yeah, so we expect this is not going to include any highlighting. Let's see what happens with the okay, so interestingly the cache tags actually work in a bit of a different way. They end up actually being if we add, like, even if the URL includes the protocol, it will still treat the HTTPS part as a cache tag. So we'll copy that. This is a bit different from how it works with the so if we add this, not what I wanted. Protocol will be highlighted as a cache tag, and I just noticed that I'll probably need to change a couple of things here and there. Then nothing will be highlighted, and same here. Yeah. And we need to go up to the user mentions because we have the same thing. Right, yep, that's the one. Yep, okay. Let's go back to the cache tags. If we add a hashtag before. And let's just complete this one to be visible, and if I can type. So we've changed this one, but then this will be span class equal highlight and span. Okay. So yeah, let's just test it. Not this. Okay, if we add a hashtag before highlighted URL. Then the highlighting of the URL will be removed, but if the first part still constitutes a valid hashtag, what the hell? It will be highlighted. So let's add something like this, and we have so this, because it still works as yep, that works. So let's see. I think haven't we included this? I think we have covered something like this one. Let's see. Let's go down. It's gonna be probably in the special characters. Yeah. So let's try and find it. Yeah, that sort of covers it, I think. Yeah, that's fine. Like, that covers it anyway. Okay, so the last thing that we have is basically pasting content into the editor and how it should be basically treated the same way. However, seeing that a lot of this is going to be probably a bit repetitive, I'll work on this just off stream. There's no point in just repeating all of that. I'd rather we actually start working today on something that's a bit more interesting, because I know that like writing tests is probably not the most interesting thing that you can do on a programming stream, but I think it was still worth actually looking at it and seeing how we can basically test something like that. So yeah, for now I'd actually rather we start working on the on building the regular expression patterns. And I'll have to admit something here, like I'm not going to be building them from scratch. As I said, like I've already sort of built a prototype for this component. If you haven't seen it, you can actually check it here, and it's TweetTextarea prototype. This is the actual code for it, and there's a live demo. So I've already sort of worked with the regular expressions, but I'll tell you what changed from the prototype. Let's just actually start looking at what the patterns look like in the prototype. So as you can see, this is probably too small, so let's zoom in a little bit. So first of all, this only included like the hashtag and mentions. At the time I didn't even realize that Twitter has something called cache tags, and URLs were a bit too complex to figure out for the prototype, so I just decided to leave them out of it for the moment. So as you can see, the hashtag pattern, basically what it does is it looks for at least one alphabetical character, and then basically any other word character in the hashtag is accepted, and of course it has to be basically preceded by the hash character, which basically tells the editor that okay, this is a hashtag, please identify it as a hashtag and highlight it. The user mentions is actually much more simpler. It's basically an add character followed by at least one word character for it to be highlighted. So that's the regular expression patterns that I've used for the prototype. What you notice in these patterns is that they only look for something that looks like a hashtag or a user mention. However, as we know that even things that look like a hashtag or user mention might still not be highlighted. Like for instance, as we know here, like if we have something like this, then I add this. This looks like a hashtag. It's actually a valid hashtag. Like if we separate it from here, it will be highlighted. However, because in this case it's sitting immediately after a valid user mention, it doesn't end up getting highlighted. However, the regular expression pattern we have here is actually going to match this bit. So technically the editor will highlight it. So what I ended up having to do within the prototype is actually doing a lot of manual checking. Like, okay, this is a valid hashtag, but does it sit next to a user mention or something that, or sit next to another hashtag? Like, if you've seen any of the previous stream, you know that like if we have two hashtags sitting next to each other, none of them actually should be highlighted. So I ended up having to build all of that logic in the prototype myself, which is a little bit inefficient because when I finished working on the prototype and actually I was already sort of thinking about ways to improve these patterns towards the end of my time working on the prototype. So we can include a lot of these rules that we've identified in the patterns, in the regular expression patterns, which means that they are not going to be actually identified. Like, so something like this, for instance, this is not going to be identified. So let's actually see what happens when we do something like that. So we'll go to the console here and const text equal this, and then const pattern equal let's see, not this, sorry, this actually. Let's copy it and go here. If we do now pattern dot text, it will actually, yeah, as you can see, it actually tells us that it's true. If we do text.match pattern, as you can see, it gives us a match to the 100 days of code part of the text. However, as we know from what we've seen, it actually shouldn't match. So what I worked on, again off stream, just after I was done with the prototype and before I actually while I was preparing to actually start working on the component, is that I started playing around with building regular expression patterns that that work basically on including a lot of the rules that I have identified from basically just testing in the Twitter editor to see how it actually works. So if we close that now, we don't need it. If we go here, log in, just log in quickly. So as you can see, basically I have a lot of work being done here, basically that I've done here, trying to figure out things like the URL pattern. And like, as you can see, things are really complicated, hashtags, and same with user mentions and cache tags. We're going to break these apart and make sure that everything is I explain everything quickly, not like that everything is explained basically in a proper way. But let me first do something. I think I can even simplify this a lot more, just to include all of that in one thing. So if I do this and remove this, I think it should still work. Let me make sure that I have google.com, something like this. If I, yeah, so it only highlights this part, and if I do this, can't just, yep, that's what we expect. Hello. Yep, that works. What happens if no? We do this. Okay, so this shouldn't be identified exactly. If we add this, it should. Yep. However, if we add that, none of it should be identified. Yep, exactly. Great. And one last thing, if we do this, all of that shouldn't be. Yeah, great. Okay. So yeah, that seems to work. So as I said, like, we're going to go through this bit one by one and try to break these patterns in a way that simplifies them, because they are generally simple. They look a little bit like they look very complicated if you just look at them like that and you don't know what is happening. But once we break them apart, they will actually make a lot of sense. So housekeeping here first. Okay, so we don't need any of this right now, and what? Okay. Okay. Export URL pattern equal this and GMI hashtag mention and cache tag. So 3 undo hashtag and make this cache tag, and this is a user mention. As you can see, we're getting errors here, of course, because we haven't defined any patterns yet. So let me think what would be the best way to actually start breaking this down, because okay, because I I've worked more on the URL pattern because, as I said, I haven't worked on the URL pattern while working on the prototype. So once I was done with it, and I was getting ready to start working on the actual component, I wanted to sort of work a lot more on the URL pattern to figure it out. So what I'll do here is I'll actually, oh damn it, I'll do this, and for now we will disable this one and just replace it with this, and what is happening here? Cannot, oh sorry. Yeah, that's my mistake. Const, and then what we're going to do is export URL pattern, hashtag pattern, mention pattern, and hashtag pattern. And for some reason I deleted this. Let's just for now do this so we stop getting errors. This will be a multi regular expression, that's correct. Basically what we have disabled here is something that gets the top level domains. As again, if you've watched any of the previous streams, you remember that a URL is highlighted in Twitter if it includes one of the top level domains, which is like the .com, .org, .net, anything like that. So for the moment I just don't want to go into fetching the actual list of the top level domains, so I'm just going to use only .com. And if we now go to the index.tsx and we actually import URL pattern from utils. No. Yeah. If we do that and we just console.log URL pattern when we start. If we now go here and go to this, oh yeah, I know what we need to do. Forgot. We just need to this. Oh, sorry, forgot. And TweetTextarea component, and what we're going to do is we are going to do yarn start So it basically will keep rebuilding everything. And as you can see, we have the URL pattern printed into the console. So again, I know it sort of looks a bit too complicated, but we're going to break it down now to actually figure out what it does. So okay, let's go back to the patterns and let's take them bit by bit. I'll ignore this bit at the beginning and this bit at the end, and I will start with this bit here. So this part is actually made up of multiple sub parts. So the first part is actually just checks for the protocol, so whether it's HTTP or HTTPS. So that's what that regular expression basically does. And then this bit checks for anything that is up to the top level domain. So all of, like, if we have something like www.google.com, then it basically, this bit captures everything up to the dot, so it will only leave the com part. So as you can see, this is the bit where we include the top level domain, and in the actual pattern that we're going to use, we're going to be getting these top level domains from a document that I found online that actually includes all of the valid top level domains. And then basically this bit includes all of everything that comes after the top level domain. So if you've been on any website, like if we go here for instance, and as you can see, like this, so the first part of our regular expression pattern will capture this bit, the second part will capture this, the Twitter dot, and then the top level domain bit will capture the word com in here, and then everything that comes afterwards is going to be captured by this part of the regular expression pattern. So again, that doesn't fully explain it. We're going to take each of these parts and we're going to actually break it down, and to do that I'm actually going to use this website that I like to use when I'm playing with regular expressions, and I always go to ECMAScript, the flavor ECMAScript flavor here, because there are some differences between how regular expressions are implemented between different programming languages. So when you're using this website, you always want to play around, basically, like pick the right flavor for whatever you're testing, because you might test something here and it works, but you've tested it on PHP, and then you copy the expression, the pattern basically, to your JavaScript code, and it doesn't work because something that's supported in PHP is not actually supported in JavaScript. So you need to make sure that you actually pick the right flavor. So let's take each one of these and just break them down basically. So I'll copy this and paste it in here. And what this does, as you can see, it has an explanation on the right side for what this pattern does. So the start here, the HTTP, it captures the literal characters HTTP. So if you type anything in here, it's not going to work, it's not going to match anything. However, if you have HTTP, once we have other things as well, like, because we're missing basically we're telling it that to expect something that has HTTP and at the end has the character, the semicolon, and 2 forward slashes, and these basically backslashes just to make sure that it actually captures the character forward slash, not something else. Actually, let me check. Yeah, no, it has to be escaped, because if we only use forward slashes, they're not going to, the pattern is not going to work properly, so we have to include this. So now if we add semicolon and 2 forward slashes, as you can see, it immediately matches it. So what we're left with is this bit, which what we're basically telling the what this part of the pattern does is that it's saying that check for the character S and match it 0 or 1 times. As you can see, matches the character S with index whatever, and then because it includes a qualifier here, I think these are called qualifiers. Yeah, not 100% sure, but I think as far as I remember they're called qualifiers or something else. So yeah, it basically matches whatever comes before the question mark here. It matches it either 0 or 1 times. So what this means is that if we have HTTP semicolon // that's fine, because the S is not included. If we add the S, then it's still fine, it's going to be included. However, if we add the S again, then that doesn't match, because we're telling it to include to match the S either 0 or 1 times, not more. If we have if the string includes the S twice, then it's not going to work. If we add any other characters in here, it's not going to work, because we're matching these characters literally. We're matching, it has to be HTTP or HTTPS followed by a semicolon and 2 forward slashes. So that's the first part of the pattern. But you notice that we don't have it just as HTTPS. We have the full thing wrapped in this strange, like the open paren and then question mark and semicolon, then at the end it ends with this. What is this called? Is it called a non-capturing group? So if we do this, and one thing that you'll notice about about regular expressions is that there are a lot of symbols that might end up getting repeated, but depending on where they are used, they mean different things. So as you can see, basically the open parentheses with the question mark and semicolon is a non-capturing group, which means it matches everything inside it as one entity. So because we want the full protocol to be treated as just one thing that may or may not exist, then we wrap it in a non-capturing group, and then we use again the question mark as we've used it in here. So we're telling it to either match it either 0 or 1 time. So if we type another HTTPS, it's not going to match both of them like as one thing. It will match each one of them on its own. As you can see here, we're basically getting the matches. So it will tell it basically this one matches the pattern on its own, this one matches the pattern on its own, but not the whole thing, like not both of them together. So that's sort of why it does. And this is not exactly the behavior we want it to have, because like if we have something like this here, we don't want, actually it ends up working. Okay, yeah, interesting. But anyway, like, yeah, because this is not the full pattern, it's not going to work as we expect yet, because the whole thing we have to have the whole pattern for it to actually work as we want it to work. Then we come here. We have this bit. Let me see what would be the best way to break this down. One second, because I think I may have something that doesn't make much sense here, really. I think we might be able to simplify it. Okay, I think no, I don't think we're going to simplify things. Let me just make sure that, yeah. Let me just make sure that, yep. have something that is not working as it should for some reason. Yeah, regular expressions can always be too fun. Let me see if I've missed something here. Maybe if we do this, base pattern dot source plus, it was working. Not sure why is it not working, and what is the problem now? Expected expression. What? Doesn't make any sense. It was working. Yeah, I think it was just acting crazy. So let's see. Interesting. Okay, I think I know what is, sort of know what is happening. That's not right. Okay, which, yeah, that is, as you can see, like I thought I have, now I have a pattern that is working as it should, but it looks like we don't. So yeah, we get to have fun and try to figure this out on our own. So let's just do this like that, because yeah, the problem wasn't in here. There's something wrong with the pattern somewhere here that I need to figure out. Okay. Yeah. So before I actually break this bit down, I think it's probably better if I try to figure out exactly what is happening. So let's just, this is the problem. Okay, yeah, I have to keep doing it here because, so why is it not capturing? Okay, I think we need this. Just need to make it greedy basically, so it actually google.com, yep, that was it. Yeah, it's just a simple fix. I missed it when I was working on that. Here we go. Okay, so let's break this down. So let's take it from small. I just want to figure out what is the best way to sort of break this one down, because we can go okay, so here's what we're going to do. First of all, one thing that I found out about URLs is that up to the top level domains, you cannot use you can use only alphabetical characters, digits, and dashes, and can use basically the dots to separate parts of the first bit of the URL. So if we have an underscore, as you can see, let's just, because Google is actually a valid top level domain, as you can see, although this is using all word characters, because if you remember, like this is like the underscore is actually a word character, it's not a non-word character, it's treated as a word character. So like if we type here regular expression \w, which stands for any word character, as you can see, it tells us that it's the equivalent of lowercase a up to lowercase z, uppercase a up to uppercase z, and then the digits 0 to 9 and the underscore. So the underscore is actually treated as a word character. However, as you can see, it's not accepted. Once we remove that, it's actually it ends up being valid. Dashes are accepted, which is a bit weird, but yeah, it's this is how the URLs work, and basically these are the only characters that are accepted. However, dashes are only accepted in the middle, so you can't have a dash at the beginning of one of the parts of a URL. So like you can't have a dash after the dot, and you can't have a dash before the dot, and of course you can't have a dash at the beginning of the URL or at the end. At least like up to the top level domain. Like if we have this, it's okay to have dashes, but like we're talking about the first part of the URL up to the top level domain. So as you can see, basically the set of allowed characters in a URL, again in the first part of the URL, before anything before the top level domain, which like if we look at part of the URL, so if we look at something like this, let's get something that is maybe, yeah, or the components of a URL. Yeah, that's a bit, this is, of course, all of that is correct, it's just, yeah, it's gonna be a bit complicated, so I'd rather not actually get into that. So just think of it that way. We're basically discussing this bit only, we're not discussing anything that comes after. Yeah? In this bit, the set of allowed characters is that any word character, so let's just type it in here. So any word character except the underscore, dots are allowed as separators between the different parts, and dashes are allowed at specific places. I.e. can't come at the start or at the end of any part. Okay, so this is basically the rules we have. We need to translate those rules into a regular expression pattern that works for us. So let's look at it. We said that this represents word characters. However, we have a problem with that. It includes the underscore, and we want to exclude the underscore. There's no way to say use the word characters except the underscore, but there is another way that you can do that. The way to do that is, first of all, you need to know that, like, when you have something like this, as we said, this represents a word character. If you capitalize the W, it basically tells this is a non-word character. So it's sort of the inverse, like the capitalized version of this expression is the inverse of the lowercase one. So as you can see, matches any word character, and it tells you it's equivalent to square brackets, and this is important because this is what we're going to use something like that. Square brackets, lowercase a to lowercase z, uppercase a to uppercase z, digits 0 to 9, and underscore. If we capitalize the W, it tells you that it matches any non-word character, and it's equivalent to square brackets, and then we have this character, can't even remember what is it called, but within a square bracket, this means that it means not, or basically it means don't match these characters. Don't match lowercase a to lowercase z, uppercase a to uppercase z, the digits 0 to 9, and the underscore. So we're going to use this syntax to define our set of accepted characters. So we're going to use square brackets, and as we know, we said that we need anything that is a word character except the underscore. So how we can do that? What is not a word character? Anything that is a non-word character. So what we're going to do here is going to include non-word characters, and we're going to include an underscore, and then we're going to include this character at the beginning, which tells it don't match anything that is a non-word character or is an underscore. This is the equivalent of saying match these. So this is what we're telling it to do, just match lowercase a to lowercase z, uppercase a to uppercase z, and the digits 0 to 9. I just find that this is probably, it looks shorter, basically. That is the reason why I use the negative version of it rather than the positive version, because it just looks shorter. As you can see, this pattern already looks way too long. If we replace this with the other version, it will just look a lot like way too long. So that is the reason why I use this, but both of them are fine. I just prefer this version because it sort of yeah, as I said, it's just shorter. So this is the first thing that you have here, and as you can see, we have the plus, which if we add the plus here and look at it, it basically explains what it does. It matches it between 1 and unlimited time. So what we're telling it to do is, if we add a character like a, it matches it. If we add an underscore, it's not going to match. If we add equals, it's not going to match. Any other special characters are not going to match, but digits, alphabetical characters, whether like lowercase or uppercase, are going to match. And it's going to match it between either 1 or unlimited time. So if we keep typing all of that, actually, as you can see, spaces are not. So yeah, because spaces are not allowed in this set of characters. So all of that is just one match. So this is what this part does. Then we have something else, because if you notice, and if you remember from what we've said about URLs, we have dashes, and dashes are allowed, but this pattern actually doesn't match dashes. So if we type Google and add a dash, it doesn't match. As you can see, it matches this bit on its own and this bit on its own. But what we want it to do is to actually match all of this as one thing. So the way to do that is, and again, we have to remember that the dash cannot come at the beginning or at the end. It's only allowed here in the middle. So the way we achieve that is by including another pattern that is allowed. And to do that, basically we're telling it either match this or that. And to do that, basically we use this line character, or like the vertical line character. This means or. This means, as you can see, it's equivalent to Boolean or. It provides an alternative. We're telling the regular expression is either find this one or that one. So like if we simplify it and do something like this, we're telling this A or B. What we're telling it here is to either match a lowercase a or a lowercase b. So if we type A, it's a match. If we type S, it doesn't match. If we type B, it's a match as well. If we type N, it doesn't match. So this is this vertical line character thing. It's basically just an or character. So if we do that, if we basically get that back and then we add or, then we have that pattern. And again, you'll see that we're actually using the same set of characters, because again, as we said, the dash is only allowed in the middle. The dash is only allowed in the middle. It cannot come, it has to be basically preceded by an alphabetical character or a digit, and succeeded by an alphabetical character or a digit. So that's what we have here. We're telling it to have basically look for one character that again either an alphabetical character or a digit, and it's not an underscore. This one has to come at the beginning, and then we have to have another one at the end, And then in the middle, the characters that are allowed here are either alphabets, alphabetical characters, digits, and dashes. Again, underscores are not allowed. In this case, I'm going to use the positive version, let's say. So I'm going to use lowercase a to lowercase z, uppercase a to uppercase z, and the digits 0 to 9, and we'll skip the dash just in case. I think we don't technically need to skip it, but like, yeah. Dash. Maybe we need to skip it. Let me just make sure. Yeah, it still doesn't actually match. And the reason is why it doesn't match, because first of all, we're missing a couple of things. We're missing this qualifier, which tells it to match it between 0 and unlimited times, so it will capture everything. So if we do this, it probably won't match as well. Yeah, that's why I expected, because what is happening now is it's matching each one of these on its own. So because this is the G is a match for this, so it matches it. This is like each of these characters on its own is a match. The reason why it's doing that is, again, we're missing a qualifier. So if we go back here, before the or character, we're missing the plus qualifier, which, if you remember, matches between 1 and unlimited times. So now if we do that, as you can see, it's matching all of that as just one thing, because, and it's actually matching against the first alternative. However, if we add this and then type this, it's actually not matching, which is a bit weird. I thought it would match, but yeah, I think we'll probably need to actually wrap this. Yeah, I think I know why is it not matching. The thing you have to know about regular expression, at least how it works in JavaScript, is the first alternative is usually if it has a first alternative and it can match something against it, then it just matches against it. So in this case, because the word Google on its own matches this, so it matches against it. The word com on its own matches against this, it matches against it. So it doesn't even get to that. So because we want to treat the whole thing as just one thing, so we'll wrap this in a matching group, and that's strange. Still doesn't work. That's very strange. Because it actually works as part of the entire pattern, but I'm not sure why is it not working. Yeah, again, as I said, like, regular expression is too fun. I find that a little bit strange, to be honest. Let me copy this. Let's see. Copied. So why is it? Okay, sorry. I know why is it not copying it. My mistake. Yeah. Here we go. now it's not even matching against this. Okay. Missing something here. Why are my regex options not showing up? Okay, that's strange. Maybe we need to refresh, because it's like something is not working properly. That's very strange. Why do my... Huh. Very strange. Very, very strange. Something isn't working properly and I'm not sure why. Refresh again maybe? Okay. Maybe let's just go to Google Chrome, because maybe something here is not working properly, and just need to find the see theme dark. I hate light themes, they're very annoying. So let's copy that again. Yeah, seems to be working here. Oh, it's not working actually. Very weird. Maybe there's something wrong with the okay, but it's still not matching it, which is a bit weird. I'm not sure why is it not matching it. Okay, yeah, I think it's still basically because it still can match each one on its own against the first alternative. That's why it is matching it. What we can do is we can of course swap the alternative, but the thing is, because the this is not the full pattern, we don't really need to do that, because once we start adding the other bits it will work. So here's what we're going to do. Like, we know that each part of the URL should end with a dot, at like each part of the first up to the top level domain bit should end with a dot. So that's what we are going to basically do. We're telling it to look for a dot at the end, and as you can see now, once we did that, it doesn't work. However, if we add the dot here, it actually matches against the entire thing. Then we need to wrap that again in a non-capturing group, and then add a plus again, which tells it to match the whole thing once, at least once, and up to unlimited time. So if we do this, it matches it. If we continue typing, again, because we don't have a dot, it doesn't match it. If we have a dot, it matches it. Do that, and we have a dot, it matches it. So that's basically this part here. And as you can see, we're telling it to find the word com at the end. So if we look here, again, it matches the characters com literally. And as we said, like in the actual pattern, we're not going to be using this. We're going to be actually fetching the top level domains from a text file and just using them. For this case, for the purposes of explaining this, let's just actually do that. This basically will do none of the, like, as you can see, though we have the dot now, it doesn't match because we don't want it to match unless it actually includes a top level domain. In this case, we're just telling it to include .com. However, once we add this, as you can see, it matches the entire thing. So we sort of have the beginnings of like a pattern that works. If we add the first bit to it, so if we add the first bit here, and I think we are missing this qualifier. Yep. Now we can also add this, and it will work. And if we can add, and we can add the S, and it will work, but it doesn't have to include that for it to work, because we're telling it it might be there, it might not. So we're saying it can be like 0 or 1 times. So if the protocol is not included, then it's fine. It will still match the URL as long as it has one of the top level domains. Again, in this case, we're just using the com top level domain. Then this is probably the most complicated one of all of them. So let me just see what would be the best way to actually break this one down. Let me just check something, because I have to make sure that, yeah, should be fine. And if I copy this here, yep, should work. Yeah, just worth a check. Okay, so another thing that I have found out about how, at least like, not, yeah, how basically URLs work is that, and how Twitter actually ends up highlighting them, is that for the subdirectories, which basically anything that comes after the top level domain, like basically something like that, or if we go to here, something like that, again, like, yeah, it's all of that is called basically the path or subdirectories. Depending on where you look online, you'll find sort of different naming. I think the official naming for that bit, I think, is the path. So if we open the documentation again, yeah, as you can see, it's called the path, and the queries and fragments and a lot of different weird things. So the official name for it is the path, but it can also be called the subdirectory. because it's like you're going basically into different directories of the website. Like if you've actually built basically like a web server and hosted like a website, like used something like Apache, you'd know that basically your website is a folder that is a directory that exists on your computer, and the main page of it is just like this index.html or index.php or whatever, and then you can actually go into directories inside. So if you have next to index.html a directory called images, for instance, and it includes a lot of images that you have, then you'll and let's say your website is called example.com, for instance. So this basically example.com will be represented by the index.html on the web server. If you want to get one of the images that you have, for instance, in a subdirectory, you'll type something like images, and let's say it's called one.png, and you type something like that. It basically will bring up the image. If of course, if you have like if you use your actual image, actual website, and you have like an images directory with images in it, you'll be able to bring it up like that. Anyway, so there are certain characters that are allowed in subdirectories. They can be used anywhere with no rules at all. Just you can use them basically anywhere. There are characters that are only allowed in the middle, so they can't come at the beginning or at the end, and there are characters that are not allowed at all. So the characters that are allowed in anywhere in the URL are basically any word character. So again, alphabetical characters, digits, and underscore, the dash, the hash character, equal sign, and the plus sign. So if I type equal sign, it gets highlighted. If I type a hash, it gets highlighted. If I type this, it gets highlighted. If I type this, and then just like, yeah, whatever I want to do with these characters, they're allowed anywhere. And this is basically what this part of the regular expression pattern defines. So we're just telling it to go back here because as usual so we're telling it to match basically any character that is a word character, a dash, a hash, an equal sign or plus sign, as many times as they are there. So if we type something like this, and then do this, and then add something like that, all of that is fine. It will be treated as no like regular part of the URL, and it will be highlighted, as you can see here on Twitter. So that's that first bit. But then, as you can see, we're using that as an alternative to a different pattern. Like, this is the second actually alternative, and I'll tell you why it is why am I using it as the second alternative. But yeah, in this case, basically, we're using it as a second alternative. So the first alternative is this. Again, we're using basically, as I said, there are characters that are only allowed if they come in the middle, and these characters are basically all of these ones. So the tilde character, exclamation mark, and at, $, %, and star, and square brackets. We're just skipping the square bracket, opening and closing square brackets, semicolon, colon, single quote, single quotation, and the vertical sign thing, comma, the dot, and the question mark. Is the double quotations not allowed? Yeah, double quotations are not allowed at all. So these are the ones that, like, if you use them here, they're not going to be highlighted. However, if you add any of like these characters that are allowed everywhere, they will end up being defined. So this pattern basically does that. It tells it to it basically says and I think I misspoke. So yeah, so these characters actually do not have to be in the middle. They just don't have to, they can't be at the end. So they can come at the beginning as long as they are followed by some of the characters that can come anywhere, but they just can't come at the end. They cannot be the last character of the subdirectory or the path. If they are the last character, they are not going to be highlighted no matter what comes before them. However, if they are followed by something else, but by something that can be highlighted, then they will end up being highlighted. So that's what the first alternative does. It basically, if we do this, sorry, let's just copy that and come here. This basically tells us that at the beginning there can be one of these characters that are allowed anywhere, but you don't need to find one. It can be like you don't have to have one of these. So you can start with one of the characters that are only allowed, that are not allowed at the end. So if I add one of these characters, one of the characters that are allowed anywhere, as you can see, it matches. If I add one of the characters that are allowed anywhere before the question mark, then it gets highlighted as well. It's fine. Again, all of these characters are accepted. Square brackets as well, dots, question marks, as we said, %, $, and at, exclamation mark, all of that. Like, it's just, the main thing is that it can't come at the end. As you can see, if it comes at the end, it's not highlighted. So, and then if we combine that with this as a second alternative, then we can basically match any sort of subdirectory. And as you can see, we here have this. So the reason why we're telling it to basically match it 0 and unlimited time is a URL doesn't have to include a subdirectory. A URL can just be the main URL. You can type google.com. You don't need a subdirectory for it to be a valid URL. So if we do something like this and this, as you can see, it doesn't come at the end. So here basically the exclamation mark comes at the end, so it doesn't match this pattern. So, but this bit matches this pattern, so it gets highlighted. However, if we add this, then all of it gets highlighted because it matches the first alternative. The reason why I'm including this as a first alternative instead of this is that if we swap them around, if we copy this and put this, because as you remember, and now it's yeah, okay, no, it's not working. As you can see, if you look here, what is happening is, because as we said, like, regular expression tends to match, and as like as I said at the beginning, see what happens here, like we have to use the correct flavor, because like the way it's handled between PHP and JavaScript is a bit different. So but yeah, anyway, as you can see in JavaScript, what ends up happening, because regular expression tends to favor the first alternative, so because this matches the first alternative, it just matches against it, and when it comes to this matches the first alternative, so it matches against it. Then each of these ones are matched on their own. However, we want the whole thing to be matched, so what I do is basically I move this as a first alternative, so it's preferred over, and if it can't find anything that matches the first alternative, then it uses the second alternative. And as you can see, this means that this string is matched, the whole thing is matched on its own, rather than matching each part of it on its own. And then the rest of the pattern includes, first of all, we wrap this thing in a non-capturing group, as we've been doing so far, and tell it to match this between 0 and unlimited times. So we're telling it, again, you don't need to find a subdirectory. If you find it, then yeah, that's good. Actually, sorry, we're not going to use this here because we're still missing something, which, as you know, the subdirectories should start with the / character. As you can see, like, it always starts with a /. So that's what we do. We add this at the beginning, so we're telling it a subdirectory will always include /. Then this is the part that we wrap in a non-capturing group, and we'll add the 0 and unlimited times, because if we have nothing, it's fine, it works. If we have a / on its own, because we're telling it, like, a subdirectory can be a /, but it doesn't have to have anything, because we're using 0 and unlimited times here. And again, like, it doesn't match the first alternative, so it looks for this, and we're telling it that this one can be 0 and unlimited times. So because there's nothing, it still matches it. So, and also if we add multiple /, it still matches, it's fine, it works. If we do something like this, google.com hello, and then we add something like this and continue typing, all of that is going to be matched as single thing, because we're telling it to match as many of this as possible. Anything that basically starts with a / and includes basically characters that match the set that we've defined here should be basically included in this match. So if we now include everything that we have, and we copy this Add this at the beginning, then follow that with the word com for now. As you can see now, basically this doesn't match because it doesn't look like a URL. However, if we add google.com at the beginning, the whole thing ends up matching and it ends up working properly. However, we're not done yet, because what we need to do is, like, what ends up happening now is, like, if I add I want to basically tell like include in the pattern the characters that are allowed before and after a URL, because some characters are allowed, others are not. There are characters that if you've added before or after a URL, they might end up making the entire thing invalid. So if we copy this here and we add a dash at the beginning, for instance, it ends up making the whole thing invalid. If we add a dash at the end, it's fine, it works. But if we add a dash at the beginning, it ends up making the whole thing invalid. However, if we add /, oh, actually, even that makes it invalid. I think the backslash. Yeah, backslash is allowed. You can add a backslash before the URL, and the URL will still be highlighted. The backslash itself is not going to be highlighted. So this part of the pattern does that. So I'll just, because yeah, if you remember how regular expressions use basically some symbols twice for different purposes. So if you remember, when we want to use the do a negation operation, basically that says that we don't want these characters included, we use this character, and that meant, like, that we were telling it, like, don't include any non-word character. This is the negation operator. This works as a negation operator when it's included within the square brackets. However, when it's included outside of the square brackets, it basically matches the start of the line or the start of the string, depending on other things. But, like, yeah, in our case, it will be the start of the line. So we're using it here, and what that means is we're telling basically, like, let's copy this and we'll explain it as best as I can, to be honest. So if I paste that here, what we're saying here is we need to either match the start of the line, or, as you remember, we have a set of characters with the negation operation. So, we need a character that is not a word character, and it's not an @, it's not a dash, it's not a hash, it's not a $sign, and yeah, and it's not a / and it's not a dot. This means that anything else, like if we put this at the beginning, as we said, like if we put an underscore at the beginning, it doesn't work. If we put a / it doesn't work. So anything else other than this group of characters like if we have any of these characters at the beginning, it will invalidate the URL. So, or like basically we're telling what we're doing is, it's just a bit hard to explain, but what we're doing is we're telling it to either find the URL at the start of the line or after a character that is not one of these. So when we go back to adding this and com and then nope, doesn't work. Okay. As you can see here now, if we add this and type google.com, it's not going to match because it's not at the start of the line and it's coming after the character that basically shouldn't come before a URL. Again, if we remove the underscore, it matches. If we add a dash, it doesn't match. If we add a forward slash, it doesn't match. If we add the $sign, it will not match. If we add an @ it's not going to match. Same thing with the hashtag. And the reason why, by the way, we have the @ and the hashtag and the $sign is because as you remember from the test that we've written, if we add one of these characters before a URL, it ends up not being highlighted as a URL. It ends up being treated, if it is valid, as a cache tag or a hashtag or a user mention, depending on the character we use. So we don't want any of these characters, like if any of these characters come before something that looks like a URL, we want that thing to not be treated as a URL. And then we have something similar at the end. Basically, let me just copy this. If we add this here as well, the $sign is basically the opposite of this. In this case, like when the $sign is used outside of anything, basically it matches the position at the end of the line. If we want to match the $sign itself, we need to escape it, or we need to include it. Like if we're matching it as part of a group, then we can include it in the square brackets, and in this case we don't need to escape it. So what we're telling it here basically is that for a URL to be matched at a URL, at the end, it either basically has to be at the end of the line, or it shouldn't basically be followed by any of these characters, alphabets and digits, an @ character, a dash, or a plus. So if we have a plus here, so yeah, depending, like because as I said, like the URL is a bit complicated. So, but yeah, in this case, for instance, this basically, these are mainly for, like they work for the top level, like anything before the subdirectory. So if we add the plus here, as you can see, it will remove the match. If we add the dash, it will remove the match, and at, it will remove the match. But hashtag, it will not remove the match. It will just be treated as a normal, which actually, as you can see, we may have a small problem in here. I'm not sure why, really. Let's go. Yeah, it doesn't. Oh, okay, I know why. Yeah, okay, we'll get to that bit. I was planning on getting to that bit anyway. So yeah, however, because like this is, these characters, like this will be valid if we only have a URL like that. Once we add subdirectories, these would not going to be valid, because basically these characters, like the at, the dash, and the plus, are already captured in here in the subdirectory, and they are allowed in the subdirectory. So yeah, they will be matched and they will be used depending on the rules of this. So yeah, just remember that basically once we get to the subdirectory, this doesn't match. Okay, and the reason why we have this is actually what we're doing right now. Once we've included this, we're telling it to basically match all of these characters. So if we include something like this, because a URL can come after square bracket, it's fine, then it will be matched, because this is we're telling it to match these characters as well. However, we don't want these characters to be highlighted, and this is where we basically use something else. Remember how we said that like open parentheses with question mark and a colon is basically a non-capturing group. Basically it's a group that matches, but you can't use it to basically capture what's inside. What we're going to do is we're going to use something the opposite of it, which is called a capturing group. We won't basically match all of that, that's fine, but the part that we want is only this part. So we want to wrap the part of the regular expression pattern that matches this part only in what we call a capturing group. So we know that basically this is the pattern that matches the google.com bit. This part here matches the hash sign, and this part here matches the open parentheses. So that means that we need to add basically a capturing group. To add a capturing group, you just need to an open and closed parentheses, and then you add everything inside. As you can see, it's similar to the non-capturing group, it just doesn't include the question mark and the colon. So yeah, that's what we need to do. We need to basically add an open parentheses here and then close them here. And as you can see now, the open parentheses here is highlighted in blue, the hash symbol or the hash character is highlighted in blue, and the part that is the google.com part is highlighted in green. And as you can see here, we have a match which matches the entire thing, but we have a group that only matches google.com. And that's what basically how this URL pattern is built. Like, I know I probably didn't make them explain it in the best way possible. It can be really difficult to sometimes to explain regular expressions, at least maybe for me as someone who don't have enough experience. It can be really hard for me to explain it. I sort of understand like what this pattern does and how it works, but even after like a couple of weeks, if I come back to it, I'll probably struggle and I'll have to go through it again to sort of break it down and figure out exactly how it works. This is the problem with regular expressions, is that they can get really complicated, especially in a case like this where we're trying not only to just match a string of text in it to basically include some things, like we also need, like we're including a lot of rules on what can come before it and what cannot come before it. Like it can get really complicated, and I'm sorry if my explanation didn't if I couldn't explain it as well as if I couldn't explain it well enough. I'm like, if you have any questions about it, like, let me know. I'll try again to explain it to anyone who asks about it. But I think the best way really is to just play around with it until you sort of get use a website like this. I think there are other ones that are fine. I like this one and I use it a lot. And yeah, break it down one by one and look at the reference here and look at like Stack Overflow or whatever, whenever I'm trying to figure out something and I don't know how to do it in regular expressions, I'll just type basically regular expressions and try to explain what I'm trying to do as best as I can. And yeah, I eventually sort of end up getting there. So yeah, this is basically our URL pattern. This is what I am using here in this test, and as you can see, basically if we do something like this and copy it to here, as you can see, it ends up highlighting it in a similar way to what we have to basically how Twitter is highlighting it. If we do google.com and add a question mark, and yeah, let's just have fun with it. As you can see, again, it ends up picking the google.com part and using it. As you can see, this is the part that is highlighted, so this is the part that is going to be highlighted if we use that pattern. Let's try something else. google.com test dash page hi, and we add this, for instance. As you can see, same thing, it picks up exactly the same thing that is highlighted here. If we add these and do that and copy it, paste it here, does the same thing. So yeah, that is how basically our URL pattern is going to work. The other regular expression patterns are not as complicated. So yeah, they should be probably a little bit easier to explain. One thing I'll just explain here is that, as you can see, let me go back here, we're using this weird string in the constructor of the regular expression pattern, which includes like GMI, like these are called basically regular expression flags. And what they do is basically they sort of tweak how the pattern will work. So we're using 3 flags. Yeah, for some reason, like usually when you click here and you open it, it shows you the flags and you can select them and it shows an explanation. But yeah, anyway, the G flag is basically the global flag, and what it does is, if we have something like this, google.com and twitter.com, we now have 2 URLs. They are both, like, each one of them is highlighted as its own URL. So the G flag basically is what does that, is it tells it basically tells TypeScript in our case that, like, match if anything in the string that matches that pattern should be highlighted. If we don't use the G flag, it will only match the first one. So, like, let's copy that text here and paste it here. That's strange. Let me check, because I think something is, as it should basically it's very strange. Let me check something. Why the hell is this so zoomed in? Let's come here and should match the entire thing. It was working before, but I think something might have happened. We'll print it here. Okay. What? Why is it not matching this? Interesting. Just maybe swap these around. It wasn't a problem before, but it's just interesting. Okay, now it's matching that. Okay, maybe there is something wrong. So why is this not matching? Interesting. So it should match it. Or is it not matching it because it's matching it as part? Yeah. Huh. That's funny. That is funny. So it looks like because it's matching the space here as part of this, it doesn't match it here, and because this is not coming at the beginning of the line, so it's not matched at all. which doesn't make sense. Okay. Let's see. Yeah, now you get to see me sort of playing around with it. So I think if we maybe added something like, what if we added 1? Okay. So, okay, I see. Problem is, I'm not sure if we've added the 0 and unlimited time that this is not going to cause issues. Down the line. Let's see what happens if we maybe add this. Nope. This will work. Okay. Let's see if there may be something that and again, that's, as I said, that's what I end up usually doing. Let's just do the checks. Match character twice. Yeah, no, that is yeah, but this is not going to do. Match character by 2 patterns. Maybe something like that. No, that is not. Special. Yeah. What is happening here basically is, because the space in this case is matched by this, it doesn't end up being matched by this because it already matched it in this first match. So when it comes to this, it doesn't find it at the beginning of the line, and it doesn't find any of these characters before it. So let's see what. Okay, let's say we're going to add this. Oh, okay. Yeah, that makes sense. Again, that will still make sense. Okay. Guess we can do that. Just have a bit of a bad feeling. Yeah, see, that is the problem. Because I think in this case, this second one shouldn't be matched. Yep. And it is now being matched. Yeah. That's why I had a feeling this is going to be causing issues. So how can we do that? Match. This is the problem. See, like, despite working on this for a while now, I still find some like issues with it, and yeah, this is why it's a bit hard sometimes to use regular expressions. Um, How do we do this? Yep. Greedy. Greedy. Rejects global match character multiple times, maybe multiple criteria. Not multiple occurrences, no. Okay, maybe can try to do this. Okay. However, yep, no, still not working. Not working correctly because this shouldn't be highlighted. It shouldn't be matched at all. What if we do something like this? Okay, we'll still have, yep, this problem which, damn it. This is annoying. None of these two should be highlighted. Now those two should be highlighted, but only one of them is, because it's not gonna do what I want. This is, yeah. Yeah. Sorry. This is really a head scratcher. Can't find them. Like, there's definitely solutions that I can sort of hacks that I can use to get around this problem. It's just probably not going to be the best thing to do. So if I can achieve that in regular expressions, it will be a much better way of doing this. This is really annoying. What if we maybe do something like this? And okay, I still think this is good. Yep. Shouldn't work at all. That works fine. Problem is this. So the issue here basically is, as I said, because this space character here is already matched by this, when it basically goes over it again to see if there are any matches, it's as if this, like it doesn't see this space. Basically it sees this text on its own. It checks if it's at the beginning. It's not. It looks for a character. It doesn't find it. So basically it thinks that this doesn't match, when in fact it should match. And the problem is, as I said, if we added like a 0 to unlimited quantifier, it will fix this issue, but it will introduce a lot more other issues. Okay. I think we'll have to just leave it here for today. Can't seem to be able to figure out a way to make this pattern work exactly as I want it to. So rather than just sitting here doing nothing, let's just end the stream here today, and I'll think about it and try to look online to maybe find a solution for this issue. And then hopefully yeah, we'll have a solution for it in the next stream, basically. If anyone watches this and has a solution for the problem, yeah, just please let me know, because I can't seem to figure this one out. Like, I'm struggling with it a little bit, and can't find a solution for this one. Yeah. Anyway, have a good night, and yeah, I'll let you know when my next stream is going to be. I still can't, like, I'm hoping that at one point I'll actually have a set schedule basically for regular streaming. It's just it's not feasible at the moment for me. So yeah, once I figure it out, yeah, we'll be streaming on a regular basis. Anyway, good night for today, and see you in the next stream.